Hello everyone. Today I have started a new lecture series that is based on thermodynamics previous year questions. So I will deal the question of GATE, IES and IAS. Okay, these will be MCQs, and I will cover almost last 20 year of questions. Okay, so today we are going to see the topic basic concepts. Okay, this is about myself. So, and those who are from thermal background like mechanical engineering or automobiles, and where thermodynamics is one of the subjects, so it will be helpful for you. Okay, so today we are going to see a GATE question. Let's start with the question. Okay, so this is a match list kind of question. This question came in GATE 1998. So we have to match with heat to work, heat to lift weight, heat to strain energy, heat to electromagnetic energy, thermal radiation, uh, bimetallic strip. Okay, so we have to match with nozzle, endothermic chemical reaction, heat engine, hot air balloon, evaporator. Okay, so let's see that. See, the heat to work is nothing but it's a heat engine, and heat to lift weight is hot air balloon. You have seen that. Okay, and one second, there is okay. Actually, there is some problem. This 5 and 6 will be here. Okay. So this A, B, C, D we have to match with 1, 2, 3, 4, 5, 6. Okay, so this should be here. So like heat to strain energy is nothing but it is bimetallic strip, and this last one, heat to electromagnetic energy, it is thermal radiation. Okay, so answer is A. There is some misprint kind of thing here, so this 5 and 6 should be here. Okay, no problem. Next question, this question from open and closed systems. Okay, so let's read that. An isolated thermodynamic system execute a process, choose the correct statement from the following. Okay, so it is asking isothermal thermodynamic system. Okay, an isolated thermodynamic system. Okay, so no heat is transferred, no work transfer, no mass transfer across boundary of the system, no chemical reaction take place within the system. Okay, so for isolated thermodynamics, actually see, no heat transfer is correct, no work done, and no mass transfer. All three is correct actually. Okay, so this question is a very old question, 1999 question. So that time there was multiple option were correct. So the here option will be ABC. Okay, so DQ now is not equal to 0, DW is not equal to 0, and DE is equal to 0, so E is equal to constant. Okay, so for an isothermal system, no mass and energy transfer through the system. Okay, so if you read about isolated system, you will find these things. Okay, I mean ABC. Next question, heat and work are okay. Isentropic properties, intensive property, extensive property, point function, path function. Okay, so actually D, path function. Next question, quasi-static process. It's a numerical. Question came in GATE 1998. Let's read that. The frictionless piston cylinder device contains a gas initially at 0.08 megapascal and 0.015 meter cube. It expands quasi-statically at constant temperature to final volume of 0.03 meter cube. The work output in kilojoule per kg during this process will be, okay, so this is the option 8.32, 12, 554.67, 8320. Okay, so see, for isothermal process, okay, work done is nothing but this it's MRT1 ln V2 by V1. Okay, so this is the formula. You have to remember this formula. It's MRT. Sometime P1 V1 ln V2 by V1 is also you can write. Okay, like here you can see that. Okay, So this P1 V1 is nothing but PV is equal to MRT, so we can say that an NRT whatever it is, okay, depends on what is given. So here P1 V1 ln V2 by V1, so everything is given, okay. So yeah, final volume is given, initial volume is given, and this is pressure is given. Okay, so we have to put these all three value in this formula. So you can write 800. See here it is given in megapascal, so convert into pascal. Okay, so accordingly you have to put the value here. And suppose if temperature is given, then you have to put temperature. Okay, since it is given in terms of pressure and volume, so you have to put in pressure and volume. So okay, so this is V1, P1 V1 ln V2 by V1. Okay, this is V2, this is V1. So if you simplify, you will get 8.32 kilojoule per kg. It's A. Okay, answer is A. It's a simple formula based question. Next question, free expansion with zero work transfer. Let's read that. A balloon containing an ideal gas is initially kept in an evacuated insulated room. The balloon rupture and the gas fills up the entire room. Which one of the following statement is true at the end of the above process? Okay, so let's read that. The internal energy of the gas decreases from its initial value, but the enthalpy remains constant. The internal energy of gas increases from its initial value, but enthalpy remains constant. Both internal energy and enthalpy of gas remains constant. Both internal and enthalpy of gas increases. Okay, so its answer is actually C. Both internal energy and enthalpy of gas remains constant. Okay, so answer is C. So you can read here the explanation. The free in the free expansion, since vacuum does not offer any resistance, there is no work transfer involved in free expansion. Here it is like we have to integrate from 0 to 2, dq is equal to 0. So q1 2 is equal to 0. Therefore, this is first law of thermodynamics. This is q12 du plus what is it? W12. Okay, so delta U is equal to 0. So its answer is like both internal energy and enthalpy of gas remains constant. Next question. Air is compressed adiabatically in a steady flow process with negligible change in potential and kinetic energy. The work done in the process is given by. Okay, so remember, an air compressed adiabatically in a steady flow process with negligible change in potential and kinetic energy. So work done in the process is given by, okay, minus PdV, integration of minus PdV plus integration of PdV minus integration of VdP and plus integration of VdP. This is actually C minus VdP. Okay, so please minus integration of VdP. So please remember that for closed system it is plus integration of VdP. For a steady flow it is W is equal to minus integration of VdP. Okay, so they are asking for a steady flow process, so its answer will be C. Next question, PdV work or displacement work. In a steady flow process taking place in a device with a single inlet and single outlet, the work done per unit mass flow rate is given by this, okay, where V is the specific volume and P is the pressure. The expression for W is given by. Okay, so we have to see the option. Is valid only if the process is both irreversible and adiabatic. Is valid only if the process is both irreversible and isothermal. Is valid for any reversible process. Is incorrect. It must be W is equal to minus inlet to outlet, okay, VdP. So actually C is valid for any reversible process. Okay. Next question. Okay, this question is looking bigger, but it's like very simple question. anyway we'll read that. And a gas expand in a frictionless piston cylinder arrangement. The expansion process is very slow and is registered by an ambient pressure of 100 kilopascal. During the expansion process, the pressure of system gas remains constant at 300 kilopascal. The change in volume of gas is 0.01 meter cube, the maximum amount of work that could be utilized from the above process. Okay, so it's PdV, work done is what? PdV. Okay, so that resistance force into delta V. Okay, so it is 1 into delta V. So just put whatever is given. Okay, so this pressure and volume, just put and multiply, you will get 1 kilojoule per kg. This is actually 0.01. Okay, so its answer is B. Sorry. Next question. For a reversible adiabatic compression in a steady flow process, the work transfer per unit mass is. Okay, we have already seen this question, steady flow process. Okay, for a steady flow, this is actually B minus VdP. Okay, so it is integration of minus VdP, so W is equal to minus integration of VdP. Okay, so this was the end of a few questions from GATE, that is topic from basic concept. I hope you like that. I will come with more questions from the GATE engineering services and civil services. Okay, thank you for watching. Bye bye.